Just right, sub in both 2 and 3 in the equation.
Well, they're referring to the graph. You are correct, but they're referring to the graph. So graphically, how do you know there's a root between x is 2 and x is 3?
Because it goes through those 2 points.
Yeah, it's literally, there it is. There's the root.
Yeah.
And okay, how do we do b?
Because it literally goes through. Oh, actually.
And so now it's to show that with the f of x.
So is it now me subbing it in?
Yeah.
And so if I sub in. And I got. I don't know if I put it in wrong. I got 0.104.
No, not that. 0.104. And the other one?
And for the other one, so I now.
What I find is a bit easier is if I just put in 1.4 and then you can just use answer. So you can do it with 1.5 now.
Yeah.
So you can press answer and that might be a bit easier. Excuse me.
I got minus 0.125.
That's good. Minus 0.125. How does that show that there's a root?
Because both those values are.
No. It's because the sign changes from positive to negative.
Okay.
They're referring to this root here. It was positive at 1.4, then it's negative at 1.5, and so at some point it must have been 0. It must have been 0 somewhere in between. So yeah, so basically there's a root in between 1.4 and 1.5, however you'd say that. But yeah, show that. So the f of 4 is greater than 0. The f of 1.5 less than 0. There's a sign change, therefore there's a root. Yep, there's a sign change, so there's at least one root between them. Okay. Different stuff, different roots. I thought my lesson was a bit better than this. 1 second. This is 0.11. This is chapter 10. Numerical methods. Yep, alright. This is as good as it gets. I do have a better stuff than this. Let's see, so this one, there are multiple roots in the interval a and b. So that one on the left, the interval is like between a and b. And so between a and b, you can see we've got 1, 2, 3 roots. An odd number of roots. Okay. Here we have an even number of roots. But there would be no sign change. So you might get that. Okay. And then here you have a discontinuity. So even though the sign changes, there's no root. Let's see how important any of that is. Okay. How about this? Hang on. I'm gonna I know what I did. I cut and paste it all into my GCSE one. This is algebra. So I made it all in the old Core 3, and then I had to teach these things in GCSE, but I cut them out. Copy of sequences. What is this called? Iterative formulae? Might be. Yeah, this is iterative formulae. Yeah, this is more like it. We often have to find the root of a function where it crosses the x-axis. We can narrow down the location of a root to between 2 points. So this value of x is a root, y is 0. Here y is negative, here y is positive. Here y is, so it can be like negative to positive or positive to negative. And this is the interval in between them. So the sign changes from negative to positive, positive to negative. So if the sign changes, that's when you get a root. Yeah, there could be more than one root. Here we've got 3 roots in the interval x1 and x2. There could be a root without the change of sign. There's a root, but the sign doesn't change, positive, positive. However, if the sign changes and the function is continuous in the interval, then therefore there is a root. So continuous meaning there isn't a discontinuity or a break in the graph. Yep, how would you do this one?
Okay. Make the equation equals to 0.
Nope.
I'll sub in both 1 and 2, and then if it's positive or negative, then I know.
That's it. So the f of 1, the f of 2. I think 1 will be less than 0, I'll give a negative answer. And the other one will be greater than 0. And so how does that show? What do you have to write down to show it?
And so we know that the value that it must have gone through 0 at one point.
How do you know?
Because if one answer is positive, and the other answer is negative, it means that in between they must have gone through 0.
That's it. And the shortest way of saying that is there's a sign change. Therefore, there's a root. Yep. Yep. The sign changes. Yep. Okay, so let me switch back to my other one now. All right, the student is incorrect. Okay, how about this?
Can we say that the student's incorrect because we can see that at one point the curve goes over the x-axis and at one point it goes below the x-axis, so there must be a positive and negative bit.
So 1.1, let's say 1.6. Student observes that they're both negative. I think it's like there and there, something like that.
Okay.
Yeah, I think it just because there's 2 roots in the interval, something like that.
Yeah.
So like it was negative, then positive, then negative again. So yeah. And B.
So just sub in 1.3 and 1.5.
Why there must be at least 3 roots in the interval. 1 point. Why would that show that there's 3 roots? Let's take a look. So part A, the diagram shows there could be 2 roots. So the f of 1 is less than 0. The f of 3 is greater than 0. The f of 5 is less than 0. And the f of 1.7 is greater than 0. Yeah, so there's a sign change here. Sign changes here, and then the sign changes again here. So there's 3 sign changes, and so there must be 3 roots, at least 3 roots. Great. I think we're good. Okay, sketch these 2 graphs. Any idea how it will show that there's only 1 root in the interval?
Is it because if it only goes like up and down once, there's 1 root or something, or?
I don't know. Yeah, like 1 point of intersection, therefore 1 root. Intersection between the graphs, therefore 1 root. B.
Do they expect me to sub in those 2 values into the equation?
Yeah, into which equation?
Both?
No.
Oh, actually, sorry. What is it in ln x minus 1 over x?
Yeah, so you'd have to do the f of 1.7, the f of 1.8, say that the sign changes, and so on. And then question C.
So, is this just me stating the answer now from the equation, or?
No, I'm not quite sure. To 3 decimal places. How do we do this? Is that using their formula or something? So, okay. So, you can use this for part C. You have to use the lower bound and upper bound. So what would be lower bound and upper bound of alpha? It was rounded to 3 decimal places.
So in this case, would it be like 1.65 lower bound?
1.6.
Oh, sorry, I was thinking a significant figure. Sorry, is it going to be 1.655?
It'll be 1.7625.
1.7625. Okay.
And the other way?
1.7675.
35.
Oh, right, okay.
So there's a way to go about it. I'll show you in a second. So what would you do with those 2 numbers?
Sub them into the equation.
Yeah. What do you expect to happen?
To potentially get an answer similar to 1.763.
Nope. You'll get 1 is negative, 1 is positive.
Okay.
2.5. You'll get f of 1.7635. You'll say there's a sign change, therefore there's a root, basically. Okay, how do you do it? So it's basically, see, this was rounded to 3 decimal places. 0.001. So that's the value of the 3rd decimal place. And so you'd have to do alpha, the rounded value, plus or minus a half of the degree of accuracy. In general, it's the rounded value plus or minus a half of the degree of accuracy. Half above, half below will round to that. Biggest and smallest numbers that will round to that value. What else was I going to say? A kind of cheat way to do it is to just stick a 5 at the end. If it's to the nearest like decimal or 2 decimal, whatever, stick a 5 at the end, and that's the amounts that you have to subtract. So 0, like alpha minus 0.0005. But we'll practice. Let's see this one. That's fine. Okay, how could we do B?
So if here we do we need to set up now 2 bounds, which will be 1.8635.
Yep.
And 1.8645.
Mm-hmm.
And then do we do those bounds plus minus a half times 0.01?
You already did all that. So you now have your 2 bounds.
And do I just times them by 0.01? Or?
No, you've already done all that. So we know alpha is between those two. Show that there's a root between those two.
Oh, because one of them will be positive and the other will be negative?
Yep. So verify for this one.
So sub in 1.8635 into the x value.
Yep.
And then I'll get... So my first value I got for 1.8635 is 0.001382.
0.00032. So that's greater than 0?
Yes.
Slightly greater than 0.
And for the next value, I just need to note it. And for my next value, I get, a negative answer. Like minus 5.31. Oh, no, sorry, minus 0.00531 and stuff, yeah.
So that's less than 0. Okay.
And so is that enough verification now?
2 more things you need to say.
So as one in the value is negative and the other is positive, it means they must have gone past 0 at some point.
That's it.
And therefore that 0 is 1.864. Sorry.
Yeah. Oh, yeah. You're right. Therefore, alpha is equal to 1.864 to 3 decimal places. Yeah. So let's see. Yeah, that's it. Let me see exactly how they said it. Choose this interval to test for the root. That one's greater than 0. That one's less than 0. There is this change of sign in the interval. So alpha is between those two, which gives alpha equals 1.864 to 3 decimal places. Great. All right. How about question B?
Is it going to be the same type of thing?
Yep.
So we're now doing 1.435.
No.
Or 395.
No. What would be the upper bound?
1.55.
Upper bound would be stick a 5 at the end, is the easy way. And so what's the lower bound?
1.4405.
Well done. And then?
And then sub those values in. get a negative and a positive, and then just say, therefore, must have gone past the 0 and stuff like that.
Yeah. So the f of 0.4405. Let me just see. So that one was less than 0. The f of 1.4415 is greater than 0. Sign changed. Therefore, there's a root. However, for these ones, what were we actually trying to show here?
That alpha is 1.441.
Yes. Don't forget, you have to say one more thing, to 3 decimal places.
Okay.
Because we don't know exactly what alpha is, but we know that it's to 3 decimal places. Okay. B, how do you start it?
So I started by doing the bounds of the number, which will be 2.2185,
right,
and 2.2195.
That's it. You sub them in. There's a sign change. What else would you say?
So yeah, negative and positive answer must have gone through 0, and so therefore alpha is 2.219 to 3 decimal places.
Correct. Okay, that's good. You get the idea. Similar. Let me see this one. On the same, sketch those two so your calculator can sketch them. With reference to your sketch, y has 2 roots. Okay, why would I have 2 roots?
Because it goes through the the x twice.
Let me see. X plus 2 squared minus 1. So that's going to be something like that. Best I can do. And so how does this diagram show that there's going to be 2 roots? To this.
Because there's two intersections.
Yeah, 2 points of intersection. Yep. Let me see. Yeah. There we go. If this is equal to this, then that, yeah, so maybe you just need to actually bring them together. So the 2 are separate, so I think you just need to say y equals, no, I think just write first x plus 2 squared minus 1 equals 2 to the x. Make that equal to 0. So you actually make them, it's like you're kind of trying to solve it. And then y equals it. I'll make it look like their one. Be the other side. 2 to the x plus 1 minus that. Yeah. And then you graph that. Okay. Alright. How about B for this one?
Okay. So sub in those 2 values into the equation.
And if you do that, you'll get a sign change.
Yes. Is this going to be again me finding the lower and upper bounds?
No. This time it says it does not have a root. Even though there's a sign change, it does not have a root. Any idea what that's about?
Is it because it's... I don't know, should I put it into my calculator to get a better understanding of why?
Yeah, go on. Put it into graphical calculator. I think it'll look something like that.
Yeah, it was a really weird drawing. Does it have no roots because it doesn't intersect with anything?
Why is there a sign change?
Because at one point the graph is the lines are positive, at another point the lines are negative.
Yeah, and what? So if the line changes, if the sign changes, why is there no root? How is it possible that the sign changes without there being a root?
Because it's two separate lines.
Yes, there's a discontinuity when x is 2. Yeah. If you sub 2 in for x, what do you get on the denominator?
0.
Yeah, and what can you not divide by?
0.
Yeah, that's why. Discontinuity at x equals 2, therefore no root. There's a sign change, but there's no root. Let's see. The equation has a single root. Use algebra to find the exact value of alpha. So then you would just solve it. You would just solve it from there. The f of 2 is undefined. That's a very simple way to do it. Fair enough. Okay, so we sketch those two. So how do we go about B?
So yeah, draw the graph and then just say because there's only one intersection.
I think you need to. So let's say ln x is like, I don't know, or something. Don't know what it look like. These are two separate graphs. That's y equals ln x, and then this is the quarter sine 2x. So what does that have to do with this? You have to spell it out.
Is it because it only intersects with the other line once?
You need to actually bring these two together. So they're both equal to y.
Yep.
Therefore?
There's only one x value?
Therefore they must both be equal to each other. So it's like you're trying to find it.
Yeah. So quarter sine 2x equals to ln x. Calculate it to get what x is.
No. Show. Make it equal to 0. Wait, 4 ln x? Oh, yeah. I think they multiply. How would you make it look like there one?
We would just minus ln x from both sides, and then just make that, because it's a quarter sine 2x minus ln x, and then just turn that into just sine 2x minus 4 ln x.
Ln x. Yeah, so then you would do y equals when that is equal to 0. Its root is when y is 0. Let's see. If a quarter sine x is equal to ln x, so they made them equal to each other, then they made it equal to 0 with it times 4. As these only intersect once, then this has only one root. Okay. 1 point of intersection, therefore one root. Yes. So 1 point of intersection, therefore this has one root. Because this is what you get when you bring them together. All right, let's see. Show that there's a stationary point. Let's see this. Okay, how do we do this?
So am I just differentiating the equation first?
Well done.
So that will be cos 2x
times the function inside the function. Times the derivative of function.
Yeah, 2 cos 2x, sorry.
Yeah.
And e to the 4x, was that like ln e to the 4x or something like
that? It'll be e to the 4x still.
Yeah.
But similar to the previous one.
And then times by 4, so 4e to the 4x.
Yeah. So that's the h dash of x.
And then do I do equals to 0?
Yeah. But we're trying to show that there's a root between these two values.
Are we subbing them both in?
Yeah, into what?
That equation, and then getting a positive and a negative answer.
Be specific. Which is that equation?
2 cos 2x plus 4e to the 4x.
Yeah, the h dash of x. Yeah, you would sub in the those two values into the derivative function, because and then you do the sign change. Therefore, stationary point. Yep. Between wherever. Yep. That's great. So that one you had to differentiate it first to show that there's a turning point. Okay. Sketch these two, bring them together. Sure. Given that, show that the equation has a root. I'm not bothering with that. X to the 4, show that there's a root in this interval. Find the coordinates of any. Given that, sketch the graph. I'm just going to see, is this worth anything? Given that, find the values. Oh, it's fine. Okay, that's locating roots. Okay, iteration. Lots of fun. Sure. Sure. Show that the equation can be written. Okay. How do we do this?
So x squared minus. So do I need to just make that equation equals to 0? Sorry, do I need to make x squared minus 4x plus 1 equals to 0?
Yep.
And then solve to get x, make x the subject and get 4 minus 1 over x.
And so, how would you do that? How would you go about that?
Are we going to complete the square?
So you're kind of used to a better way of going about this. Unfortunately, the purpose of this is let me just go back a second. The purpose of this. So these types of equations, it's all good. Yeah, if I asked you to like solve that equation, a quarter sine 2x minus ln x equals 0, it's not as easy. The whole purpose of this is to find the approximate solution. So you might not be able to get an exact solution like sine x minus ln x. You might not be able to solve that equation algebraically, but you can get a root numerically, like to 3 decimal places, which is like, it might be close enough for what you need. So these are about finding approximate answers, as opposed to like algebraic exact ones. Okay, this one. Make x the subject, add x to both sides. What do you get?
If we add x to both sides, we get x equals to x cubed over 12 plus 1.
Yeah. How would you make x cubed on one side by itself?
We would then do 12x minus 1 equals to x cubed.
12x minus 12, I believe. You would have to multiply everything by 12, all three of them.
Well, alright, okay. Yeah.
And then tricky one last.
X squared the subject. So we would do would we first of all make x cubed a subject, which would be 12x minus 12.
So yeah, we have
we
x.
think you root that and then square that or something, or oh yeah, just square that. Sorry, yeah.
Another way to do it, strangely as it is divide everything by x. So you know all these good ways. These are kind of bad ways of going about it. Yeah. Divide everything by x. What do you get?
I get 12 minus 12 over x.
12 minus 12 over x. That's it. And now the first one has x equals. Make all three of them x equals. So what would you have to do to the second one to make the left side x?
Cube root both sides.
And the last one?
Square root both sides.
That's it. And so that's it. X equals this one up here cubed, this one the cube root, this one square root. Okay. Rearrange the one on the left to look like the one on the right. And don't worry about the n plus 1 and n for now.
Okay, so I think if I do minus 2x minus 2x, actually, equals to minus 9, sorry. So 4x minus 2x cubed equals to minus 9.
Right.
And then factorize out x to get...
No. They have a cube root on one side.
Yeah, they do, yeah.
Make x cubed the subject first.
And so if I do minus 2x cubed equals to minus 4x minus 9.
All right, I'm making everything positive.
Okay.
Yep.
Divide both sides by 2 to get 4.5 plus 2x.
Yeah, I'm swapping those around. Yeah.
And then we can cube root from here and get our answer.
Yeah, cube root and move that down a bit. Whatever, what can I do? The cube root of 2x plus 4.5, and then the one on the left that's by itself is xn plus 1, and all the x's on the right side become xn.
Okay.
So that's cube root, and so make x cubed the subject. That's, you know, square root, make x squared the subject. Let's see this one. Right. Okay, how about this?
Okay, fine. So if I now do, yeah, I think that's simply x cubed equals 7 minus x, then cube root that to get x equals 7 cube root of 7 minus x.
Minus x, yeah. X equals cube root 7 minus x, and they might ask you to then xn plus 1, the one by itself, and xn all the others. Let's see this one. All right, how about this?
Okay, so if I do, I think if I do x cubed plus 7x equals to 5, then factorize out x and get x squared plus 7x, 7 plus 7, sorry, equals 5. And then just, do x equals to 5 over x squared plus 7.
7, that's great. Let's see. Sure. Okay, convert this to a recurrence relation. What's the... We've already made it x equals, so what do you do at the end?
Is that just me doing like n plus 1 and stuff?
Yeah, so what becomes n plus 1?
So x becomes n plus 1, and the x cubed also becomes n plus 1.
Just xn. So the one that's by itself is xn plus 1. All the other x's on the right side, you know, on the other side, become xn. It'll make more sense in a second. That could. No, it's fine. So let me go back. Okay. Okay. X0 is 2. How do we go about this? We have to find x1, x2, x3. Oh, excuse me. Oh, do you know how to do this already?
Does that mean now to get x1 I now need to sub in 2 into that equation?
Yeah.
And so that would be 2 cubed over 12 plus 1, which would then be...
All good. How would you get x2?
Then sub in that answer into x2, and then sub in x2's answer into x3.
And so what you can do is kind of skip to the end. Just so the first one was 2, so just put 2 and save that as answer.
Yep.
Everywhere there's an xn, replace that with answer. So that's gonna be answer cubed over 12 plus 1. And so press equals, that is x1. Press equals, that's x2. Press equals, that's x3, and so on. And if you keep pressing equals, what's going to happen?
We'll get x4, x5, x6, etc.
And I'm going to hold it down, and what happens is it stops, the digits stop changing because we've located this root to whatever 10 decimal places or whatever it is. So it's not an exact value. It's not like the cube root or whatever, like it should be, but it's not bad. Might be good enough for our purposes. So try this one. That is 6 plus 0.2 sine 2 xn. You can see how I put it in. So try putting that in your calculator with 6 as your initial value.
Okay.
And see if you get the same x1.
Okay, and so now we need to just do... what's this? I'm for some reason. Oh.
So you have to save it as 6 first. Oh, because I'm in radians, is that why?
For some reason, I'm getting like 6.04 and that kind of stuff.
I'm in radians. You're in degrees, are you?
Yeah.
That's a bad example on my part. Hang on, let me. Let's see. See, this is in my GCSE thing, but you can see how I brought it from A level because it's radians.
Yeah.
Okay, find all 3 roots. There's a root there. There's a root there. There's a root there. These were the 3 things we found earlier.
Yeah.
How can we use them to find roots?
So each of those equations represents one of the roots on the graph, doesn't it?
Yeah.
So am I meant to now sub in the values on the graph into the root or something? Or?
Change. So let's take the first one. That could be, xn plus 1 equals x cubed n over 12 plus 1. So choose an initial value for that.
-4.
Okay. And so do like -4 equals, so that's saved as answer. And then do answer cubed over 12 plus 1.
And I got -13/3.
So keep pressing equals till the digits stop changing.
Yeah. So I got my final value was -1.93393 etc. times 10 to the 52.
Oh, it's going to keep. I think yours is spinning out. So try a different initial value then.
So should I try like 1?
Yep.
Okay. And yeah, it's consistent. I just get 13/12.
Press SD.
Which is 1.08.
Okay, so that one's 13/12. So that's that root. All right, use a different one to try to find a different
root. 3.
Okay, but I think you're going to get the same root again. Go on, try it. Try 3's initial value.
Number.
Because we've got the 2 other equations, I mean. But you could try that again. I don't
know. So just should I try -4 for a different equation or something? Or?
Yeah.
And so if I do that. And so now I'll just do cube root of 12 times answer -12, and then yeah, mine's reached, so I got to -3.88.
Okay, great. So that one's like 3.88. and you could then do the last one, and that you should get the -4 one.
I got minus 3.88, sorry.
Oh, minus 3.88. Minus 3.88. Ah, yeah, that's not that one over there. That one over there looks like it's 2 point something. Yeah, I think you get the idea.
Yeah, I think so, yeah.
Yeah, okay. So these are, now this equation, if you had to solve this thing, be long and difficult, but using this method, just make x the subject, and then just keep pressing equals, and you can get a root. You know how we use the solver function in the calculator?
Yeah.
So it uses a similar method to this. That's why it only ever gives one root. It doesn't give all the solutions. It gives one root because it's using this method. Let's see. Yeah, all right. I'm skipping back to the other one. Right. So how do we do B?
So we're now going to be... Do I need to sub in that equation into my calculator, get some roots, and then start subbing them into the iterative formula?
Yeah. They tell you x0 is 3.
Oh, so I can just make the value. So I do 3 is equals to answer.
Mm-hmm.
I do 4 minus 1 over answer, and I keep on subbing values in to the point where I've now got my highest value is 3.73.
Answer. And so then you get x1 is 11 over 3, x2 41 over 11, and then x3 is 153 over 41. And I even have my little thing down here. I'll keep that for later. There we go. We got them. I use this equation. We showed that the equation has a root. Okay. And so how would you do B?
Just 1.5 equals in my calculator, and then just continue to do it for 1, 2, and 3.
And then for part 2?
Make 4 equals like as the answer in my calculator, and then do that for 1, 2, and 3.
Yeah.
Yeah.
Let's see. That's fine. So we did those ones. Sketch the graph. Write down the number of roots. Yeah. x0 is 2. Rearrange it to that and do that one. Let's see. Sure. Root sign change. Yep. So it's just bringing this stuff all together. Just putting them all into one big question. That's all they're doing. And so this is the type of stuff. See this one, x equals ln 10 minus whatever. Like that would be a very difficult equation to solve. And so that's why you use a numerical method. Let me see. So these are the exam questions. Yeah, find f dash. Show that there's that. Use the iterative formula. See, look at that crazy stuff. Arc cos. Yeah, to get the first 3. Yeah, so you give some approximations, and then you can just keep pressing equals a million times and get it very close. Okay, so we didn't do B a little bit. Calculate the values. Show that there's a root between these two values. Yep. Okay, iteration. What do you give yourself?
Probably a tick.
Yeah, that's all right. Yeah, how was that for you, Andrey? And so, continue this next time.
Yes, please. Yeah.
We'll probably finish this chapter next time. It's all right. any questions from you in general?
I don't think so.
All right, well done, Andrey. You did great. I look forward to chatting again next time.
Thanks. See you on Friday.
All right, take care. Bye bye.